let me draw a diagram over here. We are having a capacitor which is connected to a battery as shown in figure. This is our capacitor. It is connected to a battery as shown in figure. Let the capacitance of the capacitor be C1. Let the potential of the battery be V1. And in this case, there is an accumulation of charge. Let's say the charge is Q1, and the energy, that is the potential energy associated with this capacitor, let it be U1. And from this state, we are, or I am just redrawing that diagram over here. From this state, without removing the battery, we are doing a small adjustment, that is, we are introducing a dielectric into the capacitor. I am introducing a dielectric into the capacitor. The dielectric of the dielectric constant of the dielectric is K. Then let's consider this as the first situation and this is the second situation. In the second situation, let me say the capacitance in the second situation, let it be C2. The potential in the second situation is V2, and the charge associated in the second situation, let it be Q2, and the potential energy is U2. We have to formulate the relation between energy, capacitance, charge and potential. That's our task. In order to say it, let's say one of these two factors will be constant in 1 and 2 case. Can you see what is the constant thing in the two things? Yes, we didn't remove the battery and there is no change in the cell also. If there is no change in the battery and we didn't remove the battery, we could clearly say V1 is equal to V2. That is, initial potential will be equal to final potential. Without removing the battery means the potential will not change. V1 is equal to V2. Then let's analyze the capacitance situation. If we are recalling our previous knowledge about capacitance, if we are introducing a dielectric into the capacitor, its capacitance will increase. And we have learned that if a dielectric of dielectric constant K is introduced into the capacitor, the capacitance will increase by K times. Therefore, the final capacitance, that is C2, will be K times that of initial capacitance. Whether if we are keeping the battery or removing the battery, that is not depending upon this value. That is, if the dielectric is inserted into the capacitor, then capacitance will increase by K times. Therefore, C2 is equal to KC1. It's not because we are retaining this battery. It's because we have inserted a dielectric into the capacitor. Therefore, C2 is equal to KC1. Then let's recall the basic expression for capacitance. The basic expression for capacitance is C is equal to Q by V. Then we could say Q is equal to CV. And if I am using this basic expression over here, I could write Q1 is equal to C1 V1. Likewise, if I am using in the second case, I could write Q2 is equal to C2 V2. Then what is C2? C2 is KC1. Therefore, instead of this C2, I could write KC1. What is V2? V2 is V1. Therefore, I could write instead of V2, V1. Then, can you identify who's this? C1, V1 is our Q1. Therefore, I could write Q2 is equal to K Q1. That is, charge will increase by K times. Then last, we are going to find out the case of the potential energy. If we are going for the case of potential energy, we could use U is equal to, there's an expression like this, QV by 2. I could use this relation. We could use any relation for potential energy, but in this case I am using this equation. Then since we are having U is equal to QV by 2, I could write U1 is equal to Q1 V1 by 2. Likewise, I could write U2 is equal to Q2 V2 by 2. Can I? Then instead of this Q2, I could write Q2 as KQ1. I am writing instead of Q2 KQ1. Then instead of V2, I could write V2 is equal to V1 by 2. Who's this? Q1 V1 by 2, it is U1. Therefore, I could write U2 is equal to K U1. Then, if we are summarizing the situation, if a dielectric is inserted into the capacitor without removing the battery, potential will not change. That is, V2 is equal to V1. The charge will increase by K times. That is, Q2 is equal to KQ1. The capacitance will become K times, that is C2 is equal to KC1. Finally, potential energy will become K times, that is U2 is equal to KQ1. Therefore, remember these formulas also. They could ask you many questions regarding this. Now, as a second case, we are going to discuss about the change in the capacitance. If we are having this capacitor and after charging the capacitor, I am isolating this. I am isolating the capacitor after charging it. Then I am inserting a dielectric into the capacitor. A dielectric is inserted into the capacitor. Then, in this case, let me say the situation is the final capacitance, let's say C2, the final potential is V2, the final potential energy is U2, the final charge is Q2. This is the second situation. What will happen to C2, V2, Q2 and U2 if the capacitor is isolated from the battery and then a dielectric is inserted? This is the second situation, and in order to speak about that situation, in this situation also one factor will be constant. Can you guess which factor? Potential will not be a constant in this case, or potential may not be a constant in this case because we have removed the battery. Then can you recall the law of conservation of charge? The total charge of an isolated system is always a constant. That is our law of conservation of charge. If we are charging the capacitor and isolating it, it is an isolated system, and in that isolated system we are adding a neutral dielectric of dielectric constant K. Then according to this situation, the charge won't be changed. That is, the initial charge that is accumulated capacitor will be equal to the final charge. Therefore, we have to start as Q2, that is final charge should be equal to Q1 if the capacitor is isolated from the battery and then dielectric is inserted. Q2 is equal to Q1. And in this case also, if we are introducing a dielectric, the capacitance of the capacitor will increase. It will increase by K times. Therefore, I could write C2 final capacitance, it is K times initial capacitance. C2 is equal to KC1. Then we'll use the basic formula for capacitance, that is C is equal to Q by V. If C is equal to Q by V means we could write V is equal to Q by C. V is equal to Q by C. Then I could write V1 is equal to Q1 by C1. In the similar manner, I could write second potential, that is V2 is equal to Q2 by C2. And if we are substituting for Q2, what is Q2? Q2 is Q1 itself. Therefore, I could write, instead of Q2, I could write Q1. And divided by, instead of C2, C2 is KC1. Therefore, KC1. Then, can you identify this quantity? Q1 by C1 is V1. Therefore, I could write V2 is equal to V1 by K. In this case, the potential is not a constant. Potential will decrease by K times. Final potential is initial potential divided by K. Then, next we have to derive the expression for potential energy. For deriving the expression for potential energy, as in the previous case, I am using U is equal to QV by 2. I am using this expression itself. Therefore, if U is equal to QV by 2 means, in the initial case, U1 will be Q1 V1 by 2. Likewise, U2 will be Q2 V2 divided by 2. This is our U2. Then, substituting for Q2, Q2 is Q1 itself. Therefore, I am writing Q2 as Q1. Then, substituting for V2, V2 is V1 by K. V1 by K, and there's a 2. I have to write 2 over here. Then, we can identify this quantity. Q1 V1 by 2 is U1. Therefore, I could write U2 is equal to U1 by K. And if we are summarizing the situation, if the capacitor is isolated from the battery, then dielectric is inserted, the charge will remain same. Capacitance will increase by K times. The potential will decrease by K times, and potential energy will also decrease by K times. Then, if we are recalling the previous situation, that is, without removing the battery, the dielectric was inserted means, without removing the battery, dielectric was inserted means, what was the situation over there? In that situation, V2 was equal to V1, C2 is equal to KC1, Q2 was equal to KQ1, and U2 was equal to KU1. This was the situation where without removing the battery, a dielectric is inserted means. This is the situation where if the battery is removed, then dielectric is inserted means. Hope you understood this situation. Remember all these formulas.